the first session, I went back and spent a little more time on this. So if you have a handout from the first session, I'd say go ahead and throw it away. This has all the same information, plus I put a lot of the things that I said about these different programs in here, so we're not going to go back over the quit programs or really too much of that. I only want to talk about two main things, the memory manager and doing some sprites. So, I'm just hoping for a little miracle here. I managed to, of course, break all my demo code about an hour ago, so that was one reason I was happy with a little delay, so I can kind of go back and try and get my stuff working. So on the, if you want to start with kind of, I guess, the handouts, we can skip ahead. We already talked about a lot of the super high-res graphics, but you may want to kind of keep this big chart out, the super high-res mega reference page, just because it's good to know through the rest of this, but we're going to skip ahead into the toolbox stuff. So first of all, kind of a show of hands, does anybody here, anyone here heard of the toolbox for the 2GS before? Yeah, okay. Has anybody used it? Okay, so you've used it.
I'm here for a refresher. Assembly is all I've ever
Well, that's the
done.
thing, is I didn't even know if anybody had heard of it, because it's obviously completely unique to the 2GS. There's nothing like it in the 2E. It's kind of weird because it's not something we would typically see in a modern computer. So, I mean, to put it succinctly, the toolbox is a set of routines, right, that's built into the firmware. Just like the cout routine and the clear screen routine that you have for an Apple IIe, the only difference is it's got a much smarter dispatcher. You don't call memory locations directly, you call the dispatcher and just say, I want this routine. And that's really important because that means you don't have to keep them in the same place every release of your computer. And as a matter of fact, they didn't when they released the ROM 3. We got a new set of toolbox routines on that chip, the firmware that they gave us then. And it also meant that it didn't matter for the ROM 1, it could go up to the ROM 3's level because you can load in tools dynamically. So you kind of have this dynamic patching system. And you can even write your own tools. I think I tell you that in here. So that's great. And then when you look at something like GSOS, it's heavily tool-based. They're using tools to draw all of the these windows. They're using tools to read my mouse, to read the keyboard, to do all of the file management. The downside is some of the tools are not so great for certain applications. So one example is here. These graphics for the menus, they're really smooth, of course, because I'm running in an emulator. And we'll take it back down to traditional system speed, and you can see how long it takes to redraw just that screen. So that's clearly not fast enough for a game. You can see when I move it, it has to undraw the window, draw all the stuff that was behind it. So it's really great from the sense that it's general purpose, great for doing this desktop stuff, but we're not going to use the quick draw tools today. We're just going to talk directly to the screen. But there is one tool that you have to use if you're really going to try and make any sort of real Apple IIGS programs. It's the memory manager. So old 2E, you're kind of in bank 0, or if you're in the emulation mode on this, you've got one bank of memory. You can write anywhere from 0000 to FFFF. With the memory manager, you always ask it, can I have some memory? When I launch a program like this, the GSOS Finder actually looks at the size of my program and it asks for memory, then it loads my program into that memory, then it transfers control over. So even GSOS has to allocate memory for your program. It's just when you start your program, the right amount has already been allocated for whatever your program is. I'm going to get out of here. All right. So I'm going to go to this guy. First of all, you may kind of take note of this. It's just an error macro that I have. Anytime you do a tool call, if there's a problem with the tool call, it'll set the carry flag. So if your carry is clear after a tool call, it means it worked, whatever you were trying to do. If it didn't, you need to do something. This is just a macro that I wrote so that I don't have to have this goofy BCC after every tool call. So let's go look at a tool call real quickly. See, this is the macro. If I didn't have this, I'd have to do some branch of carry clear because it came back okay, otherwise handle the error. So this just expands a little error guide that basically if there's an error, it branches off somewhere and does like a fatal exit. I'm not going to talk too much about error handling. So here's the same start we talked about yesterday. You set your data bank because you just launched from who knows where. And you want to be able to read and write to the memory locations in your program. So you set the data bank. Now we're going to start up the tools that we need. You always have to start the tool locator. No problem. We're talking about tools and the very minimum that we need, and I'm saying that the memory manager is the one guy that you're really going to have to interact with, whether you want to or not. So you start the tool locator. This is that dispatcher guy that I was talking about that knows where all the other tools are. It returns a result, so you have to pull that off. And actually, let me back up. On the same page that has the toolbox stuff on here, it tells you what you need to do to make a tool call. So first of all, if there's a result, like let's say you're asking for a memory handle, you need to give it space for a result, so you push some zeros or whatever on the stack, and that's where your result's going to be after the tool call. So that's step one. In this case, TL startup, there's no result that we have to prep for. We just pull the result off. How do you know which ones do and which ones don't? Well, you kind of need the GSOS toolbox reference. That's one thing I'm trying to address. And it looks a lot like this page right here that has an example of what the kind of API for a tool call is, and that particular one is handle. My formatting is a little different than the book, so you can't accuse me of copyright infringement because I typed it in myself. So, like I said, you push space for any results on the stack before you make your tool call. You load the number of the tool call into your X register, and then step 3, JSL E10000. That's where all tool calls are on every GS. If the tool locator gets updated to a new version, it gets patched in there. So you're always going to do the same thing. You're always going to call to that JSL E1000. So if you see this code where I have a TL startup on the screen, that's the same as this top box on the toolbox page. So you can see I'm using some Merlin macros here. So to do a tool locator startup, like I said, you would load the tool, in this case, number string, or 0201, which means call toolset 01, which is the tool locator, and then command 02, which is TL startup. It's important to know this, and don't be afraid if you kind of don't get all that right now. Just kind of know that it's there, and you can see when we compile these what these macros expand to, these TL startup. But really what's more important is to learn how to use these API references and just know that you need to do a push long, a push long, a push word, a push word, and I'll give you an example of that. But before you can go allocating memory, just know that these are kind of the steps you need to do. You start your tool locator. Notice that I don't check for an error here. The tool locator should never ever error when you start it up. If it does, I mean, something has gone catastrophically wrong with your 2GS, So,
Probably not running anyway.
right, so it's just one of those things, technically you should always check for an error after every tool call. I don't here because if something has gone wrong, I'm so screwed it doesn't matter. And just letting you know, like, maybe that's bad style, but the GS hasn't really been updated much in the last 20 years, so it's worked pretty well. So, MM Startup, I don't think I gave you the call for that, but there's not much to it. You just push on one word, now in this case it's whatever's in A, so if I did an LDA 0, it would be like pushing this on there. So what we're going to get back, we do this memory manager startup, it returns an ID, so we pull that off and store that as our master ID. This is how the memory manager knows our program. When it started up our program, it gave us this ID. And now that we started up the memory manager, it just told us what the ID was. Then this next command sets our auxiliary ID, which you don't use this part, it's just here. And you have up to 16, so you can go from, or I think 15. I think you can go from 01 to 0F. Why would you do that? Well, if you're writing a really complicated app, you can actually dispose everybody allocated under a certain ID. So just know that. I normally only need one ID, but basically if I had a set of different handles, I could go, okay, all of these handles reference images, and at some point they've closed all the images, so I want to get rid of these, and I don't want to loop through all the images. I'll just destroy everything associated with that ID. Don't have to get that complicated, but just letting you know that's what we typically do. You pull off your ID that it gave you, this master ID, and you give yourself a user ID. I generally use one, and that's fine, and I just allocate everything with that. Just so you know, when you quit your GSOS program, if you use a normal GSOS quit call that we talked about last time, you don't have to dispose your memory. It's going to get tossed anyway, which is kind of nice. So we'll see that we actually don't. So anyway, if I want to allocate memory now, I have to use this user ID, and this is where we get into this the new handle page. Go to the actual allocation. This is actually a pretty good example. So, if you look at the requesting a block of memory, you'll see it has long result space. Right? So that's going to be the space for our result, and here's the code that does that right here. I just do push long 0, and that basically puts 2 words on there. That's a Merlin macro. It's going to expand that into actually 2 separate pushes to do a 16-bit, or I mean a 32-bit value, right? Longs are 32-bit now. So this is a macro to help. The second thing we push on is the block size. So right here, does this number ring a bell to anybody?
64K to me.
Right, exactly. So obviously, if you wanted to, you could probably actually request a handle of 0 bytes, and it would give you back a handle that references 0 bytes. So if you ask for 10,000, it's going to give you a whole bank. You give it that user ID we talked about next. That's user ID in here. This is the one that we stored earlier, that 01 masked onto our master ID. And then the memory manager attribute bits. This is another one that's kind of rough if you don't have the toolbox reference, so I made sure to include the memory manager attribute bits. The main ones to know here, remember, GSOS can move stuff around. You can actually ask the memory manager to go try and find memory and clear it up. So you can say, how much do you have free? And it will say, oh, I only have 32K. And you can say, well, can you purge something? And it'll actually go and look for blocks that are purgeable and purge them, depending on how you set that. It'll look for things that are movable and see if it can just reorganize them. So this is really important. If you look at what I'm doing here, that first bit says it's locked. You're never going to move my block, okay? I want that handle back, that way I can dereference it and just play with it like standard old school assembly. I don't have to check every time and go, oh, what are you pointing to? The second is also another restriction. And just think of any time you set a bit in this memory manager attribute, you're really giving it more restrictions. The second one says, also don't move it. Okay, then we go to these bits. I haven't really told it anything about the purge level. It's just set to 0.
Can't be purged.
Right, right. And then here's the important ones for this. If you're going to do game programming, you'll want these, or some sort of like if you really want a full bank. So the next one says you're not allowed to cross bank boundaries. And remember, we've asked for 64K, so it's got to give me a full bank of memory, right? So that we're awesome after this point. If it doesn't have a full bank of memory, this will fail. So generally it doesn't fail if you just boot it up a GS, especially on an emulator, but you should remember these things can fail and you should handle that if you want to make like proper desktop software. May not use special memory. It doesn't really affect us in this case because it wouldn't be able to since we're allocating a whole bank, but you'd have to go look at the reference manual for what special memory is. So, sorry, I don't have all of them memorized, but and then the last one that I told it is that it must be page aligned. Again, this is kind of silly because it's going to be page aligned because I just asked it for a whole bank. So, but anyway, that's the kind of tricky part. If I didn't set these, I could have it anywhere in memory. If you were asking for a smaller block, let's say you just wanted, 1,000 bytes or something like that, then you may still want a lot of these, like having a page aligned and things like that, just because that's still obviously useful. So this does the, this gets converted into LDX and
Sorry, didn't cover that you were pushing at a 0 for the address.
oh yeah, I'm sorry. So I did push 0 after that attribute bit. If so that basically means I don't care where. If I gave it an address and this is documented on there, but if I gave it an address and set one or both of the last 2 bits, one is give me this bank, one is give me this address, then it would try and give me that specific address. Not really sure what programming circumstances, I mean, maybe for low-level system stuff.
It's for, yeah, there's situations like if you're playing with a video overlay card and you want to, which keeps its graphics memory in bank E1,
Okay.
and you want to be able to grab that memory to be able to write to it and stuff.
Yeah.
You want to be able to say, hey, I want bank E1 2000 or whatever.
That's true, yeah.
Reserved for me to play with.
Yeah. So you could specify banks of known memory locations, or banks and addresses of known memory locations, which you would need to do if you were using other tool calls that operated on handles. Or you could spoof a handle, but that's probably not something people should do. I don't know, I've never tried it, but
Well,
I mean,
why not?
I think a handle is really just a pointer to a pointer.
Yeah.
I don't think it has any other metadata, but by locking it, you can just dereference it right after you do this new handle. And this is actually an interesting routine. It's a little different than what most people do. Since we're allocating a whole bank, when I pull my result here, it returns it as a long, right? That's what we pushed up here from the result space. I'm doing something a little weird. I pull the base address to X, and then the high address. This is not swab the accumulator, it's supposed to be swap. So really what I'm doing here is I don't care about those low 2 bytes of the address. I know it's 0. I asked for a page aligned. I got a whole bank. This is actually going to be 0 too. I know it is because I asked for a whole bank starting at 0. So, and I said that it couldn't be over bank boundaries. So really all we care about is the bank address here. And that's why I really only return the bank address and the page address and not the full 24-bit address. Does that make sense? Because I can make the assumption that I'm starting at 0, 0, 0, 0, because I got a whole bank. It's not going to start at 0, 0, 0, 1. So it's a little unusual, but it works out well for these kinds of little demo programs. Now, the way we requested it, like I said, this gives us a whole bank to play with. And what I did here is I made a little load picture routine. Well, all right, I might have borrowed it if you notice the French. Go back to the first one. Yeah, that's where so I got that code that's allocate one bank from the Brutal Deluxe guys. Before, I would have always passed back the full 24-byte address, or 24-bit address, I would have properly handled it. And then I realized, oh yeah, they're right, I don't have to, because I've got the whole bank, and then it makes kind of your whole life easier. You just go around overriding the bank on your routine everywhere, and that's all you have to do to kind of reference this memory.
And the really cool thing is, if you change your bank register to the bank that you just grabbed, then you don't need to use long instructions.
So we kind of went over that the other day, but yeah, that is a...
So you like using long instructions in general?
No, I mean, I just didn't want to get too much into it for this, but that's a lot of times probably what you would do.
Right.
It depends, I mean, so at this point I'm using compiled sprites, so all that goes out the window. But it's doing that in the compiled sprites too. It's either using bank tricks or stack stuff,
Yep.
or a mixture, shadowing, does all that. But it's good to know. I mean, yeah, you can totally switch your bank up, and then the problem there is, you know, if you're using a whole bank for something, it's probably big enough stuff that you're still going to have to do it long somewhere. But what you can do is, let's say you've got image data in one bank and the screens in the other, well, you could always just switch your data bank to that image bank. So you're doing local loads and long stores. I don't know if it's cheaper to go the other direction, you switch that around, but I'll let you guys figure that out. You're all smarter than me.
I've used maybe one or two computers you haven't yet.
I bet you've used a lot of computers I haven't. I don't get around much.
Well, there's one of the computers.
Somebody's making fun of me for using a Mac now.
Who's making fun of you for using that?
So Scott, because I made a big point of me not, you know, I did everything on Linux the first time, or the last time I was here. And I would, but, so now I have to use Xcode to make iOS apps.
Right.
I have to use VisualStudio.net for stupid Windows stuff.
And you want
Which
to use
means
MPW.
Right, right. So basically right now I'm forced to carry 2 laptops for work, and it's like, do I really even want to fight for Linux at this point? So I've acquiesced to at least use the one that has a shell and VI built in, so I don't hate life altogether.
And there's one more file, you just run an emulator on both OSs under your Linux.
I do that, and I hate it. They all suffer some performance penalty, obviously.
Yeah.
But virtual machines are awesome, they're great, but ultimately, then I get mad about the fact that I have to run them in virtual machines because they're making me run the wrong OS in the first place.
Your fans blow and you get mad.
Oh man, I don't know about you guys, but I'll forget about this guy back here
Right.
at top running speed, and then all of a sudden it sounds like a jet's taking off.
Yeah, I have that all the time.
Get those nice little lap burns.
Little personal information there, thanks for sharing.
No, I don't let it sit there that long, but it gets a little toasty. I do not like that. So I'm loading this guy. This is a lot of the code we just saw, right, the tool startup. I allocate a bank, and then I store it in this variable, which just has, again, what I'm calling a bank pointer, which is basically the bank and page, right? And the page is going to be 0 again. So then here we've got a routine called load picture, and so I load X with the location of the picture name, and then I jump to this subroutine. It loads it in a very specific place. Then load picture actually loads it to wherever we allocated our memory. It knows about bank load. Sorry, that uses a little priori information.
It says in your comments that it's using the accumulator for the bank. To use
Right.
loading, which
Is
grabbed.
bank load, yeah.
Yeah.
So I tried to comment this almost every line. So
So
there's a
that
couple
loading
of
bank
things.
load actually. Oh, what, you're coming back, whichever you can see.
Right, so then I probably trashed it up there, so I load bank load again, and I think there's a little header there of 80 hex UnpackBytes. Either way, you don't want to copy this data. I'll go back and try and clean that up a little bit.
Oh, no.
Oops. Actually, I forgot about that. Yeah, I'll grab my guy over there. So anyway, the picture in load picture is already uncompressed. Load picture takes care of that. We'll talk about UnpackBytes in a minute. So it's at this uncompressed location, so basically this is just a normal copy loop, right? And then I turn on the graphics. Let's see if this will work. Right. Yay, so we've got a little KansasFest start there.
Yeah.
I'm gonna let you guys stare at the beautiful 2GS while I plug in.
Handout, the same as we got the first time.
No, it's an updated one.
Oh.
It's better.
It's better than the first one.
It's
You're supposed to throw
1.1.
away the first one.
It's a little more book-like.
You're supposed to throw away the first one. Oh.
Thank you for making it.
Oh, no problem. I'm gonna try and clean it up some more. Maybe not. I don't know. I'm not sure how to continue this beyond here, but
But you'd like to in some way.
I'd like to. And honestly, some of this is stripped out of a larger library that I wanted to provide, so that people can really just include 1 or 2 macro files and not have to worry about any of this, like not have to do
Yeah.
any of the load picture. Now obviously you can use that load picture routine I just gave you, but I'd like it to. It's not 100% generic right now. So it uses a little bit of known information about my code, which is obviously a little nasty, dirty, whatever.
Did you ever do any classic Mac programming, or was it always 2GS?
2GS, and I didn't even do much Apple IIe programming because my first assembler, I already had a GS by that time finally, so unfortunately. So I did a little bit of x86 assembly
Right.
when I finally gave up and got one of those, and that sucked.
Did it? Is the assembly less fun for some reason on x86?
It's probably okay now that I'm older and I know more about programming, but I liked that the GS had succinct banks.
Right.
The x86 has kind of a sliding window, so it can address memory.
8086.
Yeah.
Yeah.
So that's fine, it just is a little
Yeah,
bit
'cause
annoying.
the addressing was, you had 2 bytes and 2 bytes, but they overlapped so that like the top nibble was
So,
different.
You know those bank pointers that I'm using? That's kind of what their memory mechanism is like. So you could have 2 pointers that actually have overlapping.
Because whenever I did, whenever I did
It's not- it's
86, I always set
Yeah, it
one.
makes sense once it
Yeah.
makes sense.
I always set one, so I only ever, that was all zeros except for the first bit, and then I used the others for
Okay.
So it's possible for you to overlap them further.
Oh, I see. I got it. Yeah.
Because you got one starting here.
So the other problem-
Window is.
The other really sucky thing, coming from the Apple II world, for what it's worth, maybe we had a limited number of, say, graphics modes on the 2GS, but once you start trying to program Visa hardware or whatever, the VGAs of the day, where you've got varying displays, there were no standards for sound cards. I mean, that was, like, you have to be full-time just writing sound card drivers.
Well,
So
that was always more. I mean, but that's still even true on like, iOS. You know the resolutions you have to code for, because there's not that many devices.
Exactly, so it kind of makes it easier in that sense.
Mhm.
So, I'll show you one other thing about this program. And again, it's just to let you know that it's there and it's working. But there's a raw GS picture format where basically they've taken that graphical memory map and they've just stored it on disk. It says file type C1 if you guys have ever seen those. You can use them in Paintworks or Dream Graphics. I'm using PackBytes, and even though emulators are really fast and they've got plenty of disk space, I would still recommend using PackBytes because it's easy and you could do a lot of neat stuff. I mean, you could load potentially just tons and tons of images on a 4 meg or 8 meg GS. So I'll just show you really quickly kind of what it looks like. Let's see. And I did give you the reference for this. It's called UnpackBytes is the one we're using. I call this load file routine, which loads our compressed image up here. And after that, I call this unpack picture, which does some of the dereferencing basically and setting the sizes up right. You can see here's where we actually make our tool call, right? Space for result, pointer to the buffer, size of the packed data, which was sent down from up above. Pointer to the unpack buffer. So this looks a lot like the new handle, right? I mean, you're just pushing a bunch of parameters on the stack, then you call UnpackBytes, and you pull off the result, which happens to be the number of bytes unpacked. You can see I'm not doing error checking here, so this program will actually probably die pretty badly. So there's some things missing. If you try and load a file that doesn't exist, it crashes. If you try and unpack something that's not UnpackBytes, it crashes. So just little things like that. And I tried also in the documentation tell you which of the files on that GitHub are related to this.
Where in the code is the file number?
Ah, that's a good question. So, oops, it's all F. I'm still searching. Right here. So this creates one of those Proto style strings that has the length at the front, which means I could print it out using my little font routine that I showed you guys yesterday without any modifications. So that's kind of nice.
What is the one?
Uh,
I have a volume code.
It's
It's
a
just-
GSOS
it's a
shortcut.
relative.
Oh, okay.
Like asterisk is your boot volume,
Okay.
and one is
So it should be, one should be the volume that it launched from in this case. I don't know if it can get set odd in other occurrences. And that may be a little confusing because if you look at some code, it'll have things like, Merlin has its own set of directory locations.
Right.
The big one is 4.
But that's Merlin, that's,
And yeah, but that's not the same thing.
got it.
And if you do this in Merlin, you can actually see that that is actually the Merlin macro library, and that's where all the macros are.
there are certain routines that you can do that with. I think York Shell may be able to do that with, say, prefix asterisk slash and give you a volume.
Oh, nice.
So when you loaded the
Very
image
soon.
in, you ran it, it was really.
Very soon, it's ordered, it hasn't shown up
Still
yet.
getting later down to like
Oh, it's still to come.
Yes.
loading, or it's still.
So the steps that I took here were, I allocate a chunk of memory, we load a compressed file, and uncompress it.
And then you got the other screen.
Yeah, I think I left room for both. I'm not sure what memory I'm using that for, but yeah, so I'm sorry, I allocate memory, load the file, uncompress it.
And then so you're
There's
doing
two
that
versions
on
of this. There's a load image and a load image 2. And, oh, and I think I'm actually looking at the old one. The one that I put online after the, oh, I gotcha, all right. Let me look at load file real quick.
You editing with Vi?
Hmm?
You're editing with Vi?
I didn't hear that.
Were you editing with Vi?
Yeah, that's what this is. Oops. Yeah, so when I load it, I uncompress it to the allocated memory. Then right at the end, I just copy it to the super high res screen. I could have sworn I had a different version that uncompressed it directly to the screen, but I guess not. So I actually want to take a break from this and talk about something else. Just because this is the fun part, if you guys want to get to this point where you're wanting to do your game or program or whatever, I thought maybe I'd go over a couple of tips on how to get art converted over. So I showed you that one. Oh, darn it. Excuse me. Oh, man, what did I get wrong? That's
I think you were up to 13 at the end of the
Rule land 13, right?
You're legit.
awesome.
I didn't say you go for the number keys.
You were bogus before.
I'm a liar.
No, you do a lot like that.
Well, let's do something else. Let's do a beach. Yay, Google Images, right? So let's try and take a nice picture and put it over there. I don't want it to be too boring, but I'm going to try not to kill it with colors since obviously we're a little limited. Which one? What do you guys think? Maybe that one or this one?
Only go one up.
What's that?
Go moving with the clouds and the tree.
Let's spend like a couple hours choosing.
Forward committee.
Yes.
The art selection committee.
That's right, art selection committee.
We're gonna schedule the-
Okay, first we have to form a committee.
So this may be unfair. I know a lot of you guys may not have access to Photoshop, but you can try these techniques with other tools. You can do it with
GIMP work?
Yeah. So the one thing about Photoshop though that is really helpful in these occasions. First, let me get down to. Oh, it's probably. All right, so there's our picture. It's got, these tools are also available up here, but we're going to go straight to the end and do save for web. So you can have it reduce colors from these true colors other ways and size, but I'm just kind of cheap here. I think it's a great tool for this because you can kind of see the results real time. I'm going to zoom it in a little bit here. And you can see, first of all, it's set to 32 colors. Now, sometimes I play with this and I'll go for something in higher color mode, save it as a GIF, and use a converter on the Apple, and let it try and do one of the multi-palette modes, right? Because you can have 16 different palettes, but you can only have one per line. Sometimes that kind of adds up to making little sort of line artifacting in your image. So a lot of times if I don't want that, I will actually go all the way down to 16. It also allows you to pick the type of dither, so you can kind of tell the difference there for pattern. It's actually using patterns of pixels to approximate it.
And all you've done here is just scale it down from 320 by 180 and 16 colors. Or is there more that you've done here?
That's it, and I haven't even saved it yet. This is actually just an export window. So you can do this in the program too, but I'm just using the export functionality to show you kind of how easy it can be. So there's the pattern one. Diffusion typically works the best. If it looks like it's got too much noise, sometimes I'll turn down the dither, but if you turn it up all the way, it'll actually do a better job of coverage. See the difference there, and you know, if it's just too dramatic. Now, if I were actually going to make something cool for display here, I would probably actually go ahead and edit this and make it all one color, and then go back in and use a multi-palette mode on Apple and do something cool back there to give it a graduated sky. But I just kind of wanted to give you an idea of what I did with that space picture. I just went out and found a picture of space, played around with this a little bit, and then saved it. Let's go ahead and do that now, actually.
You know,
Hold on, quicker here.
What you need,
Which one?
graphic converter, the program.
The
Paper convert.
It's been around for 100 years.
I know there's a couple.
It does a lot. I wouldn't be surprised if it could.
I know there's at least, or in the old days, there was at least one Mac program that could output some of the Apple formats.
Yeah, graphic converter.
Yeah, graphic converter is one.
Okay.
Yeah, this is definitely a lot faster than super convert, unless you're on and even on an emulated machine, that's still really good.
Right. Well, those are, I mean, just some of the things to kind of, I guess, keep in mind when you're doing that. The other thing is, what I did for the game assets that I was going to do for a game, and that will actually come, but it's going to have to be after the conference, obviously, is I wanted to give myself enough colors for the sprites, so I limited it even further. Something like that. Now you can see I actually didn't lose a ton by going down to 8 colors. It wasn't that great to begin with. But this, basically, I set it down to 8 colors, so I've already got another 8 colors to play with for my sprites. So if I wanted to have something completely different over this, and it didn't match any of these. So that's kind of a good way to start. The other thing you can do if you're planning on having some multi-palette stuff, like I said, is go ahead and maybe blank out some areas, save it out to 16 colors, save it separately, and then do all that editing on the GS side. I'd like to provide some better conversion tools in the future, but right now it's kind of everything is custom, and I think it's up to you to be artistic about it and figure out the best way to squeeze out good-looking graphics from modern assets. So yeah, I'm going to take that little detour, show you basically how I came up with that picture. And the one last thing that I want to go over is sprites, which is the last page on here. So if you guys saw the part about the fonts, I can actually show you my font diagram. I'm actually going to do it in VI in a second. Oh. So the GS doesn't have any accelerated sprites, doesn't have any hardware to draw stuff for you. It's really just like I showed you the other day with the font engine, where you store stuff to the screen locations, like I am right here. I'm just storing it to different places in Bank E1 between 2000 and 9CFF, where that pixel data goes. So if you look at this top example here, I kind of gave you the starting of something that looks similar to the font routine, but this time it's just a routine that draws the ball, knows how big the ball is, and it's just saying load the first word of the ball, store it to the screen, load the second word, store it to the next dot on the screen. In this case, it's, you know, F is whatever the color of the ball is in our little guy, and 0 is, let's just imagine it's black, and that's the background. So the problem with that approach is that you're going to have a ball with a square around it. It's not going to be masked over the background. So let's say layers over here if I can. Layers. Oh, even further over. Bigger screen now. This guy. Okay. Oops. I don't want it to pattern fill. Color. Pattern program. Okay. So let's assume that this is kind of like our ball, and the F is the white color. Right. So like I said, the problem with the routine that we just had is that I haven't done anything but copy the data. So assuming that 0 is a black color, the problem is we'll end up with something like this, right? that's not what we wanted. So there's a tried and true method that everybody's pretty much used. You can use it even really in the 2E modes, but it's obviously a little different since the memory layout for the 2E high-res graphics is a little convoluted. So what you do is these steps down here, and I'll actually come up here. These are just plain, they kind of go along. If you want, you can look at your sheet. So we just work from left to right. The first thing you do is load some screen data. In this case, I put all 3s here. We're going to assume that the background color is 3. Right? Let's just say it's green or something, or blue. Then you do a logical OR with a mask. I'm sorry, I think I've got this all backwards. Yes, I'm sorry, that is backwards. Too late, it's already been printed. So you're going to want to reverse these. We do a logical AND. So everywhere that those F's are in the second box, it's going to keep. Everywhere that it's not, it's going to wipe it out. So what that's going to look like is, it would look like blue everywhere except for where the circle is. And instead, this is going to be black. So basically, we take the screen and we punch this hole out of it, ending it with a negative of what our shape looks like. So, just to visualize that, we take a copy of our screen. Oops. It's not going to let me do it when it's hidden. That destroys the illusion. We take a copy of this part of our screen, and then we use this mask, which is the opposite of that white ball, and punch a hole out. And that gives us the result that we see in the middle. And like I said, just if you want to cross these out and put AND over here and put a OR over there, that's the only thing I screwed up, sorry. But anyway, you can see that that's the same result we have down here. So now we have the 3s, that background color, the blue, with 0s all punched in the middle. Then we AND it with our ball, so that basically draws in whatever the ball color. So if it's white, it's going to draw it in here. And then we store that result back out to the screen. So again, that's really what you typically do to draw a sprite if you need it to be masked. I'll provide some good source for that. It is generic, but
If you're not like this, you may want to take that to the,
oh yeah, I bet I was trying to go into VI. I keep doing that in other programs, and it turns out that not everybody respects VI commands. Jerks. So,
Question, should that stay as all mask or should that stay all?
no, it was just the logic that was wrong. So it really is a ball mask, but you're supposed to AND it. And does that make sense? What the result of the ANDing is anywhere that there's nothing there, it's going to leave a hole. So, let's see. Now, I would, if you really want to get into this, I would actually go read some of the Brutal Deluxe stuff, because even though he's really more interested in his Sprite compressor, he talks a lot about this and how you would do it kind of in the typical way. But he also provides a really nice compressor.
the GS version of Death Star.
Yes, he is. Also known as Barbarian. So I don't know if he's how far along that is, but that's what he appears to be working on.
I didn't want to do a GS version last time.
I've been wanting to do a GS version of Short Circuit for years, and then the guy just did, what is it, Dino Eggs?
Yeah.
Yeah, so I saw the article, I guess they did a new release of Dino Eggs. I was like, man, so I wrote him and I said, I've wanted to do Short Circuit for years, and I thought it would be so perfect for mobile because it's not overly hard, it's single screen. I was like, and I didn't know you were around, so I'm glad I didn't do it. I didn't know what he paid to have done a dick, but I'm sorry. But, so yeah, he's like, no, I'm still around. That's an interesting idea. So maybe I can get his blessing. Now, I don't care if I get his blessing for the GS version. I'll do that. Can't stop me. So this is actually a much better interpretation interpretation. See how he's got a sprite with a bunch of data? This is what his mask looks like.
Mhm.
So if you load this screen, take the sprite and the mask, you punch out the area where you want your guy and draw it all black basically through that and then you get the foreground and background. So if you, what's that?
So is the task of putting the character on the beach just a matter of changing that one asset and create someone?
Basically, I mean, so once you've got a routine that can mask like this, you can draw it on top of anything. Now the tricky part is, do your sprites
Use the same
colors
palette.
match the same palette as that? And that's where there's.
Can you Google image search by palette? Like, let's say you're looking for
really.
something that has a lot of your colors in it.
There's some search tools where you could pick by color, but ultimately I think it comes down to how you handle what you call your asset management pipeline. Like if you were working in a game studio, even they have to do that where somebody's making 3D assets in Maya or 3D Studio. Well, the game probably uses a custom-made format that has special things it needs to know about other stuff in the game. So even modern development studios tend to write their own tools that handle getting the art all in there.
I'm gonna guess that you don't go to one of those schools you see on TV to learn about that.
I don't know. I don't know how successful those are. I mean, maybe they do work. But anyway, yeah, he actually does a lot of probably better explanation of a lot of this stuff, what it looks like if you didn't mask it out. You know, you just drew it on using that naive where you have the same background we were talking about. Here you can see, even shows you, they did the Lemmings game for GS, so for all of those sprites and things, this is actually a whole set of sprites they use just for this animation to spit that guy out. They have a set of masks. And here it goes in, does a much better job of showing you the masking. But what's really cool about his tool is if you are patient enough to kind of set it up, is it'll compile it. And it does all this analysis. So here it's got full sprite bytes, meaning that it doesn't have to mask these, right? It's only when there's a guy here at this byte, needs a little bit of background and a little bit of sprite. So you can optimize by saying, well, I only want to store one byte right here. I don't need to mask it. If I tried to do a word, it would actually be all 4 values right here. So you can see it's 4, 4, 4. So he says, well, I could just do 2 and save on the masking. And it's that much better to actually switch to an 8-bit accumulator or registers and write 1 byte out than it is to use 16, load in, and, or store. So that's basically what his thing is all about. It goes through and optimizes that, and then I think at the very end, I apologize if you've already seen this. Yeah, he shows you basically how it scans through and does that and breaks it down into full pixels. These red ones are super highly efficient. This is using stack, these big chunks where he actually relocates the stack. These are like full word stores. What's yellow?
Is that why it's not going strictly in order from top to bottom?
Exactly, because certain things like reloading the stack, he tells you exactly why too. There's so you'll notice he does all these ands and ors before he does the stack part. But anyway, all you really need to know is that it generates a really fast sprite. It can also do things like shifted sprites, which I haven't talked about, but let's say you want to draw a mouse cursor. Well, you're going to have 2 sprites, right? Because they're byte aligned pixels. So you're going to have one where it's on the left and one where it's shifted 1 pixel to the right. Unless you want to make a routine that actually shifts all those, but that'll be very slow to shift everything by a nibble, right? So this can generate pre-shifted. It can also do flipped sprites so that it'll generate a left one and a right one. It's pretty cool. And this shows how large of a sprite that you can actually do at 60 megahertz with a compressed sprite animation.
Are you going to use his stuff for your future stuff, or are you doing your own stuff?
No, I have. The only difference is there are some weird things about it. So for example, he has this thing where you can draw a border around it.
Yeah.
It's not discussed in this, it's discussed in Mr. Sprite. Why would you need a border around it? Well, you'll find out really quickly if you have a sprite like this. It freaks out, it thinks it's two sprites. It doesn't realize that the shadow's connected, so you can draw something around it to let it know you want that to be one sprite. The problem there is that it's still, look what it's doing here, it's automatically lopping off the edges to be faster. That screws up your sprite sheet though if they're all perfectly aligned.
Right.
And then you have to either have a set of indexes to tell it how far to offset everybody. So the version that I have allows you to skip that because it shouldn't make performance difference. It's an addressing difference in the compilation. Right? You're not writing to these empty locations. You're just, so my version handles that.
Have you talked to him at all about this?
Oh yeah, I had to get the code from him, and I showed him some of it, and I got stuck on one part. Stupid Windows does wildcard resolution totally differently than Linux and Mac. So
Yes,
on
it
Mac,
does.
if you say ls star.gif, it's on the command line, it's actually going to pass in ls and then the name of every GIF file. On Windows, if you say ls star.gif, it passes in the string star.gif. And you got to go write your own code to loop through the directory, find all the GIFs. So it's fine. It's just Windows APIs are not something I really want to learn. So I've had to a little bit. I've gotten it all working on Mac and Linux, and I said, hey, I'm ready to give it back to you. And then
So Mr. Sprite, this is all Windows code.
this is Windows code. Well, it's yeah, but it's command line. So it's all command line, but I'm like, well, if you're gonna make it command line,
I know,
I can do them with
well, there you go. And, well, that was the thing, is he was open enough to let me get a copy, not really knowing me at all. I was like, hey, I love your guys' work. Can I please port this? Specifically because I don't want to use it on Windows, because I have all these nice build scripts. And those I can't easily port to Windows. I'm not going to write batch scripts. It's not.
You don't know. That's not gonna happen.
I've done hardcore batch scripting before, and it's dumb.
You can install, what do you call it? The full Unix stuff for Windows.
Oh, yeah, I mean, there are a lot of solutions
What's
for
that called?
that.
Sigma?
Yeah, that's,
Cygwin, there's a userland Linux that's pretty cool, but it's kind of deprecated.
but,
So there's solutions, but
right, but,
yeah. So, let's see if I can find the locations here. Yeah, I don't know about this. I'm going to see if I can show you an example of what the Mr. Sprite stuff looks like. Something in motion. That's more exciting. If I had had another hour, I would have had a really great demo for you guys, but
we good.
I'll do it all later. And then, so I'm actually going to keep up a little bit with the demo stuff, but there is a very simple game that I will release in a week or two, because I put it in here. I'm not going to have time to really talk about sound or input. So if you want to do something, feel free to use what you know about input on the Apple IIe, like the keyboard strobe and reading that. But you should know that there is an event manager that you can use in one of the tool sets, and it traps all input and gives you a nice event queue so you can read events off of it, like process that queue. Very much more modern. And if you don't want to do that for mouse input, and you want to write your own mouse routines, I'll tell you right now, you're going to have to make sure it works on the ROM 1 and the ROM 3, because they switched, there's no slot 3 mouse on the ROM 3 or whatever. They kind of switched that up a little bit, so you can handle it both, and it's not a big deal, because like I said, it's an old enough system. I think that's fine, but just know there is an event manager out there. Writing desktop software, you have to use the event manager. You can't, because what actually happens here is the window manager uses the event manager. But but we're skipping all that. So let's see if I can get a little demo. It's going to have the same, mostly same picture. Probably fail a bit here because I didn't have time to test the drawing location, so you'll see all of the tricks exposed. Yeah, see, I'm off by a couple lines.
Background too, yeah.
So, this is the one that I saved using that export stuff. You can see I just got it so close. I just added a couple more lines before I compiled it this last time. But this is good. You can see that I'm using a scanline setting here. So this is a red gradient palette, and I kept this down to minimal colors. It's not many colors. And unfortunately, you can't see it. Mr. Sprite actually is drawing these with masking. I was too lazy to undraw it, so I'm drawing a big black box over it, which you wouldn't see if it wasn't right there. That's okay. So just trust me that it is actually drawing these shapes masked, but in between each frame. So actually this is kind of interesting. We're running at 2.5 megahertz. When this turns, oh, it's going to quit. When this turns red, that's the start of my, basically my drawing routines. That was just something I put in for timing. I actually carried it over from their example so you could see how long it was taking to draw those two toruses and the black boxes and update the sound. So we had a lot of time left, really. So you could be doing a lot of those sprites. They're very, very efficient. And like I said, I'm not going to get into sound, but what I did for the sound on that was just use the noise tracker tool set. There's also a Soundsmiths tool set. And it's really easy to use. I have an example of it, but the last thing I'll show you is how I got that music. It's not mine. It's from an Amiga mod file. Have you guys all played with Noise Tracker or seen that before?
Yeah.
Right.
We use Sonic Tracker, Monjet.
Right. So those are actually better players, unfortunately. Noise Tracker is not highly compatible. They've got that nice tool set, so if you want plug-in music and you don't know how to program the Sonic dock oscillator chip, which I would recommend you don't. I would say try and use tools if you can. So these are mostly horrible songs, and a lot of them don't work. I'll just pick one randomly that probably won't work. It says it did. So let's see if I try and play it. I can guarantee this is not what it's supposed to sound like, right? But if I took that song, and then after I did the Amiga import, I say module, and save it out there somewhere as whatever. That's what I'm basically doing to convert it to the format that we need. Whatever. Then if you look here, I load the file to a known place, and oh, actually, I don't even think I do that. It has its own file loading thing. Well, no, it is using read file again. So all I have to do to use that guy's tool set is make sure I have the tool available on my GS. If you want, there's a linkable version too, if you want to make sure that it plays even if people don't have the tool. I just call the startup like any other tool set. And again, this is the FTA's tool set. Like, it's not an Apple tool set, showing that you really can create your own tools for the GS. Read the file, do an init music and a launch music, and that's it. I mean, that's all. This is all the code it took to play that song. Granted, read file is a Protos file reading routine, but that's pretty much it. You can see again, I have this little VBlank routine. I look for a specific place. And this is actually interesting. Why did I start there? Instead of waiting for the actual vertical blanking period, I'm looking for a specific line. It's up to you, but remember how I said you can't update the full screen at one time? It's just never gonna happen, if you're writing out pixel data. But let's say you were comfortable with updating every other frame, you could do a lot, right? Especially if you wait for right here and let it get past this line, and then you start going. You're never gonna be as fast, but you're gonna have more time before it goes back. So you could maybe update half the screen and make sure you always are not in there. So, or ultimately, let's say you were doing sprites and they're all over the place. You could make sure that your drawing routine is always starting here, drawing sprites from top to bottom, and you could potentially get a lot more done because maybe it's second pass through and you do beat it. So that's what the point of this code is. You can actually time things that way. Instead of looking for just the overall vertical blanking period, you can look for specific scan lines and say, okay, well, it gets here. I don't remember why I chose that value. I think I was just being silly. It's good to know if you ever want to make those really nice, smooth animations and things like that. So that's really all I have, because I've tried to put as much as I could into the actual documents. And like I said, it covers everything from Monday. Sorry it's not great about explaining the assembly, but I just wanted to really give everybody something they could use as a reference if they want to go look at my code online, because it does cover what all that stuff is doing. What's up?
Right, just sort of a basic question.
Here, I'll turn this up.
It's sort of a basic level. And I don't know if you covered this before, but you could have used Merlin, or you could have used Orca if you had chosen.
Right.
And what would be the reason?
Well, so I may eventually go add some Orca stuff so that the lessons are really available for both. I would, yeah, it's just familiarity. I'm better at Merlin. Yeah, I mean, it's definitely my favorite compiler, but that's no longer an issue for me, right?
But
So,
even with an accelerator on a large program, that there will be a difference. Because I still have weights with stuff.
I think if you were doing desktop software, there could be a case made that Orca is going to be better for you, because if you get the whole Orca suite, you can write some stuff in C, and that's certainly advantageous if you know C. And then you can link your C programs and your Orca assembly programs together.
Now you can use MPW and compile it. Native, right?
Yeah, I missed that session. I really wish I knew how to do that. But
It says something, I don't know exactly.
was that your session?
No.
Oh, okay.
But it said something about incorporating Orca assembler, I thought.
Well,
Yeah, the MPW suite has an assembler and a C and a Pascal. It's the same as Orca.
So that means
it's
you
just on the
no
Mac.
longer need to buy Orca? As long as you're writing stuff from scratch, like you're not trying to use something.
If you're cross-compiling, no, you don't need Orca at all. You can just use MPW and compile stuff.
and you could really use any compiler to do all this stuff. Like all these tool calls that are this. I mean, this NT launch music didn't exist. I found it in their code, and I had to go back. Oh, it's not in there. Yeah. I don't have it. I actually had to go back and reverse engineer what their tool calls were. So these are macros that I made.
That's one thing I like about Orca M is you can do macros with parameters. So you don't need to do your pushes and stuff like that on there. You just do the tool call and push your space, put your space.
Right. So
and all your parameters and brackets.
you can do that, and their Merlin supports that format too.
Oh, right on.
So we're like a function call?
Yeah.
Yeah, and the reason I didn't is because I was trying to find a good balance between showing that you're pushing along
Yeah.
versus to push words.
Oh yeah, when you're doing an introductory thing.
I'm glad you said that because I had the question, but I didn't want to distract from the assembly part.
So
It
let's
seemed
see.
more pure to see that. I wasn't sure. To me,
So-
it was like, it seemed like it would make sense to be able to
A lot of
the macro.
Yeah.
Well,
yeah.
sometimes you don't want to because the way you want to play with your parameters
You
and
might
stuff.
want to change
Right?
something. Yeah.
Because it sometimes, like say, it will automatically pull stuff off may automatically pull something on the return off the stack for it, but you may want to leave it there for your next call, right? So sometimes you want to use them, sometimes you don't.
So this is a good example though, just to show you what the parameters look like. 0 is, are there any parameters? And then it's the parameters after that. So this is kind of like, if there is a parameter, then we're going to go ahead and pull, a word, which actually uses the code above it, expand, you can have macros that include other macros, right? And then pulls another word to the location that was passed into this. So basically, if I did this, if I called it as a long, whatever, your handle, it would go ahead and pull a word and store it to handle, and then store it to handle +2. Otherwise, if I didn't give it an address, meaning I just called pull long, it's just going to pull it and discard it. I mean, it'll leave the last one pulled on in the accumulator, but so that's what the variables are in there. So if you have multiple, let me see if I. Oh man, this is definitely not VI. Right. So, see, I've been using these underscore versions, hand pointer, where you have to set up everything ahead.
Yeah, it's the tool ones or
The tool ones.
I didn't know Maryland 16 had that.
Yeah,
Cool.
it has the same thing, and you can see what it does here. It's actually calling this parameter thing. It's another macro of its own. It passes everything through, and then it falls through to the next macro. Right, so there's a very important relation to how these are ordered in here. This is the end of the macro. So if you call this one, it expects you to have set it all up. If you call this tilde one, you can just pass everything after it. So you can do a nice, and then to pointer, A, B, C, or something like that. Or I guess it is actually like that.
It's common, I believe in.
Yeah, I'm not sure. I haven't used them in a while. But yeah, so if you're working on a big project, I'd say do that because it's probably going to be more readable in the long term. Especially, I think if you guys ever decide to dabble, you'll find that there's maybe 10 things you regularly do. You start up tool sets, you ask for memory, you may start up a sound tool set or something like that, ask it to play it.
If you're doing System 6 stuff, there's a startup tool called that.
Thanks, Dave.
I'll keep updating the online stuff. So, anybody else have any other questions? Or?
With one call.
Oh, really?
Yeah.
Let's see. But if anybody has any questions, I'm happy to answer them. Otherwise, you've got my email now, so feel free to hit me up online.
Thanks a lot.
No problem. Thanks for coming, you guys. Thanks for sticking it out.
Thanks for, sorry.